this module, you will learn about the classification of materials. To be able to understand the need for classification of materials, first let us look at some important devices such as the vacuum tubes, which were the initial diodes or triodes, etc. These devices were used in the earlier part of the 20th century in electronic circuits. First, let us try to understand the term electronics. In the strict sense, the word electronics refers to the science and technology of the motion of the charges in a gas, in vacuum, or in a semiconductor. The motion of charges in vacuum was studied in devices called the diodes or valves, and subsequently in the triodes, tetrodes, and pentodes. A simplest vacuum tube, called the vacuum diode, which consists of two electrodes, is basically made up of an anode, often called the plate, which is the positive electrode, and a cathode or the filament, which is the negative electrode, kept inside an evacuated glass tube. When the cathode is heated, energy supplied to it helps the conduction electrons to overcome the electrostatic attractive force of the surface of the cathode, and they are set free to leave the cathode surface. The flow of the electrons is controlled by varying the voltage between the two electrodes. Vacuum is essential in the inter-electrode space of a vacuum tube, as it helps to prevent any loss of energy that would otherwise take place if the electrons were to collide with the air molecules in their path. When the anode is kept at a positive potential, as compared to the cathode, which is at a negative potential, due to the potential difference, the electrons move from the cathode to the anode in one direction only. Vacuum tubes are also referred to as valves, as in these devices the flow of the electrons is only in one direction, that is, from cathode to anode. As such, they are useful for receiving radio signals. Some of the common types of vacuum tubes used are the vacuum diode, the triode, the tetrode, and the pentode. The vacuum diode has two electrodes, an anode, and a cathode. The triode has three electrodes, a cathode, a plate, and a control grid. The tetrode has four electrodes, a cathode, a plate, a control grid, and a screen grid. And the pentode has five electrodes, a cathode, a plate, a control grid, a screen grid, and a suppressor grid. However, in spite of their widespread use in earlier times, vacuum tubes have certain disadvantages. These are: vacuum tubes are bulky, they generally operate at high voltage around 100 volt, they consume high power, they have limited life as the cathode electron emitting materials get used up in the operation, low reliability as they are more prone to microphonics because the mechanical vibrations are transformed into an undesired electrical signal, also referred to as noise. Glass tubes are physically fragile. These disadvantages in the usage of vacuum tubes led to the search for devices and materials in which the number of charge carriers and their direction could be controlled without the added disadvantages of the vacuum tubes. The use of materials called solid-state semiconductors and devices made from them called the solid-state semiconductor electronic devices helps to overcome these drawbacks of vacuum tubes, as it was possible to control the number and the direction of the flow of charge carriers in them. In the semiconductor devices, the flow of charge carriers is within the solid itself. However, at low temperature, the charge carriers are not free to move as they do not possess sufficient energy to move. The charge carriers can be freed to become mobile charge carriers in a semiconductor by heating, applying a small voltage, or exciting through light. Use of semiconductor devices has many advantages, such as they are small in size, they operate at low voltages, they consume less power, they have long life as the solid-state material is durable, high reliability as they are less prone to microphonics. To fully understand semiconductor devices, it is important for us to understand the classification of materials on the basis of their electrical conductivity. We have learned that electrical conductivity or specific conductance is a measure of a material's ability to conduct an electric current, whereas electrical resistivity, also known as specific electrical resistance or volume resistivity, is a measure of how strongly a material opposes the flow of electric current. Solid materials are broadly classified into three categories on the basis of their electrical conductivity or resistivity. These are conductors, semiconductors, and insulators. Conductors have very low resistivity and high conductivity. Their resistivity ranges between 10 raised to the power minus 2 to 10 raised to the power minus 8 ohm meter. And in particular, metallic conductors possess conductivity in the range of 10 raised to the power 2 to 10 raised to the power 8 Simon per meter. Some examples of conductors are copper, nickel, etc. Insulators have very high resistivity and very low conductivity. Their resistivity ranges between 10 raised to the power 11 to 10 raised to the power 19 ohm meter. Their conductivity is in the range of 10 raised to the power minus 11 to 10 raised to the power minus 19 Simon per meter. Some examples of insulators are wood, rubber, etc. Semiconductors have resistivity and conductivity which lie in between that of metals and insulators. Thus, they have lesser conductivity and higher resistivity than metals, and higher conductivity and lower resistivity than insulators. Their resistivity ranges between 10 raised to the power minus 5 to 10 raised to the power 6 ohm meter. They possess conductivity in the range of 10 raised to the power 5 to 10 raised to the power minus 6 Simon per meter. Some examples of semiconductors are silicon and germanium. These semiconductor electronic devices may be made up of different types of semiconductors, such as elemental semiconductors or compound semiconductors. Elemental semiconductors are single elemental semiconductors. They belong to the fourth group of the modern periodic table of elements. Silicon and germanium are the most commonly used elemental semiconductors. Compound semiconductors are formed by using two or more elements. They are synthesized using elements from groups 2 through 6 of the periodic table. Compound semiconductors may be further divided into different types, such as inorganic compounds like cadmium sulfide, gallium arsenide, cadmium selenide, etc., and organic compounds like anthracene, doped phthalocyanine, etc., and organic polymers like polypyrrole, polyaniline, polythiophene, etc. You have now reached the end of this module. In this module, you have learnt that vacuum tubes are also referred to as valves, as in these devices the flow of the electrons is only in one direction, that is, from the cathode to the anode. In the semiconductor devices, the flow of charge carriers is within the solid itself. Solid materials are broadly classified into three categories on the basis of their electrical conductivity or resistivity as metals, semiconductors, insulators.